I'm so excited to come your way again, and we're still on the subject of chemical bonding. And in this lesson, we will be learning about covalent bonding. And I'm so very glad that you have clicked on this video. This means that you are very much interested in what we are learning, or that you want to also check what type of resources do we have here. So I'm so glad you've clicked on the video. And I must say that one important law of success is consistency, right? The more consistent we are, the more we are able to achieve our goals. So I hope this lesson on covalent bonding is going to help furnish your understanding about any problem that you might face in covalent bonding. And I hope it will also give you a very strong foundation for your future learning in the field of chemistry. So now that we have said all that we should or that we could about ionic bonding, and we said in ionic bonding that ionic bonding involves the transfer of electrons from metals to non-metals. Remember that, from metals to non-metals. And we looked at the different metals. We have metals in group 1 and metals in group 2, reacting with non-metals in group 6 and group 7. Now, covalent bonding involves the sharing of electrons between atoms. So in a nutshell, what we are going to be talking about here just involves sharing of electrons, how atoms share electrons together. And this sharing is not between any other element than the non-metals. Okay, so it's a type of bond. If I would give you like a full sentence definition, a type of covalent bond is formed when a pair, now start to note that these are words that you have to pay attention to, when a pair of electrons is shared between two atoms. When a pair of electrons is shared between two atoms, and we have said, what type of atom are we talking about? We are talking about the non-metal atoms. Now, can you give me examples of non-metals or non-metallic elements? Can you give me examples of non-metallic elements? Yes, good. Oxygen. Yeah, in fact, I can start from hydrogen. It's good. It's a good place to start. Hydrogen is a non-metallic element. Oxygen is a non-metallic element. Or any other one? Yes, fluorine is a non-metallic element. I can put carbon here. Carbon is also a non-metallic element. And can we also write some other ones in that group? In group 6, you can have, what other element can you have? In group 6, you can have sulfur. In group 6, okay. We can have chlorine. We can have any other element. We can have bromine and the likes of it. So these are the common elements. You can just look into your periodic table. Remember, the non-metals are found on the right-hand side of the periodic table, while the metallic elements are found on the left-hand side of the periodic table. And the element at the center of the periodic table are referred to as the transition elements. So now let's look at something to help our understanding so far. Imagine if I give you compounds like this. And let's say I have Na2, CO3, CaCO3, SO2, and also have CH4. And then I ask you that which of the following compounds, or what are the types of bonds formed by the following compound? Or can you just tell us the types of bonds that each of these compounds can form? The only way to answer this, if you can answer that, that's good. You can just check what we have together now. Hydrogen is a non-metal. Chlorine is a non-metal. So the only type of bond that these two can form together is covalent bond. So remember, covalent bond involves non-metal atoms sharing pairs of electrons. Now, sodium is a metallic element, and these other two are non-metals. So in between these other two and sodium, we have ionic bonding because we have a metal and a non-metal. The same thing goes to calcium and this. Calcium is a metal and these two are non-metal. So the only type of bond that exists between them is ionic. However, these two elements, carbon is a non-metal, oxygen is a non-metal. So in between these two, we have what we call covalent bond. Again, what was this? Good. That is covalent bond. And why? It is non-metals. What about this? Brilliant. It also involves covalent bonding because they are non-metals. Now that you have an understanding so far of what we are saying, let's move forward to see what happens during covalent bonding. Now, it is important for me to let you know again that atoms share electrons with each other to get full outer shell or to have the highest energy levels. We call the outer shell of atoms, the outer shells of electron, we call them energy levels, right? So, and that what I just said is to answer the question of why do elements undergo chemical bonding? They do that because they want to have their outer shells or their energy level. They want to have it filled up. They want their energy level to be at the highest level possible, the highest level they can attain. So that's what they want to have. They want to have a stable structure like the noble gases. And again, to add to that is to let you know that they only share electrons in their outer shells. Atoms will only share electrons in their outer shells. They will not. So if an atom has 3 shells, right? The only shell that will be involved is the outer shell. That's the last shell of that atom, is the only shell where electrons can be transferred or shared. So again, to say that they will only share electrons in their outer shell, and both atoms involved in the bond will end up with extra electrons in their outer shells. So when atoms react together and they form chemical bond and they are using their outer shell, at the end of the day, because they want to become stable, they will achieve that stability by getting an extra electron added to their outermost shell. So, and we've talked about that. We've talked about that when we're talking about how ions are formed and when we looked at ionic bonding. So I'm just trying to emphasize this important statement so you can keep them in mind as we go on. Now, each single covalent bond provides 1 extra shared electron for each atom. So let's start with an element like chlorine. Okay, we're going to start with an element like chlorine, and to save space and to just keep our mind together, I'm only going to be dealing with the outer shell, since The inner shell has nothing to do in this case with bonding. So I will only be referring to the outermost shell of the atoms. So for chlorine, we know that chlorine has 17 electrons when it is neutral. So in the outermost shell, remember the smallest shell will take 2 electrons, and every other shell after the smallest shell can take a maximum of 8 electrons. So the first shell we get 2, the next shell gets 8, and after that we'll be left with 7 electrons in the outermost shell. 7 electrons in the outermost shell. So now, how many electrons does chlorine need to become stable? Yeah, it needs 1 extra electron to attain stability. So chlorine can form or undergo bonding with another chlorine atom of its kind. So if we have another chlorine atom, which is also having 7 electrons in the outermost shell. It's having 7 electrons in the outermost shell. Okay, now what would they do? In covalent bonding, we have said that it involves non-metals. Now, what would they do is they are going to donate 1 electron each to be shared by both of them. And this is what I'm saying. So both of the chlorine atoms like this, and we'll put them together here. We're putting them together here to show you that the electron is being shared. So the first chlorine needs 1 more electron, so it donates 1 electron. And the second also needs 1 more electron, it's also contributing that electron. So that in their shells now, there will be 6 electrons left. 6 electrons of not bonded pairs of electrons. Okay, so now do you see they both contributed 1 electron, and now they can share it to have a complete outer shell of electron. And can we check that? For the first chlorine atom, if we count, we have 1, 2, 3, 4, 5, 6, 7, 8. So this chlorine has the outer shell to be complete. Now, can we check for the second one? The same way, 1, 2, 3, 4, 5, 6, 7, 8. So the outer shell is filled up. And what would be the formula? The formula is easy to write because here you just count. We have 1 chlorine, 1 chlorine, and that's 2 chlorine, and it will be written as Cl2. So anytime you see compounds like this, H2, O2, N2, now you understand what is going on that, okay, these compounds or these molecules have formed covalent bond with another atom of their type to attain a full outer shell of electron. Now, can you do the same for oxygen? Will you try that? You can pause the video right now and then try if you would be able to do that for oxygen. All right, if you've done that, can we look at it together? Oxygen has how many electrons? Oxygen has 8 electrons altogether. Now, the smallest shell will take 2. We are not going to draw that. So the outermost shell will be left with 6 electrons. So oxygen is left with 6 electrons in the outermost shell. And now, how many more electrons does oxygen require to become stable? Great. It needs 2 more electrons. 2 more electrons. So oxygen can undergo bonding with another oxygen. And this is 1, 2, 1, 2, 1, 2. So 6 electrons each oxygen. Now, how many pairs of electrons do you think they will have to contribute to attain a stable outer shell of electron? Will it be 1 or 2 each? Yes, they will have to donate 2 each because they both require 2 more electrons in their outermost shell. So they have to contribute 2 electrons each. And that is going to open a new knowledge for us now. So now if we draw the shell and we see that we're going to have this. So the first one we give 2 and the second one we also give 2. So that how many electrons will be left now that is not involved in bonding? There will be 4 outside of each. So 4. And this we also have 4. Now, can you see that when we count the number of electrons together for each of them, you have 1, 2, 3, 4, 5, 6, 7, 8. The same thing go for the next one. 1, 2, 3, 4, 5, 6, 7, 8. Now, what is the new thing that we are learning here? Remember, for chlorine, it was only 1 electron that was shared, that was contributed to make a pair, right? So if we want to talk about the type of bond, it is a single bond because just 1 electron was being shared. In the case of oxygen, 2 electrons was shared, 2 pairs, or let me say a pair of electrons was contributed each by each of the atom. So that will be a double bond. The double bond is just telling you that, okay, each of these elements have contributed 2 electrons each to attain the kind of stability they want. So can I leave you to do that of nitrogen and hydrogen? Now, you will also see something different with nitrogen if you try that out, right? Because what is the atomic number of a nitrogen? So immediately you write that and you show the outer shell of electrons, you're going to see that that will give you a new definition. So if you do that, what were you able to come up with? Good. You see that they have to contribute how many? 3, yeah, because nitrogen will have 5 electrons in the outermost shell. 5 electrons in the outermost shell. So how many does this nitrogen require to become stable? 3. So it will have to contribute 3 pairs of electrons each to the new nitrogen. So they will have to both contribute 3, 3, and 3, 3, so that they will be having 2, 2 there. And what type of bond do you see there? That will be triple bonds. Triple bonds. Triple bonds. So this is a simple way to start to look at ionic bonding. Ionic bonding. Now, if you have any question, anything you want me to clarify, could you just let me know by leaving a comment in the chat area. So far, we have looked at covalent bonding between atoms of the same kind, right? Now, let's look at covalent bonding between atoms of different elements, And I'm going to start with water, right? The chemical formula for water is, and before we even come about talking about the chemical formula, it's good, you already know the chemical formula for water, but let's see if oxygen and hydrogen are going to form a bond together. And you will see the reason why the chemical formula of water is what it is. So far we've seen that oxygen has 6 electrons in the outermost shell. And now we're going to resort back to our dot and cross because we have different atoms. So oxygen has 6 electrons in the outermost shell. And hydrogen only has 1 electron in the outermost shell. Hydrogen has 1 electron in the outermost shell. So this is oxygen and this is hydrogen. Now, how many more electrons does oxygen need to become stable? Oxygen needs 2 more. How many more? So oxygen needs 2 electrons. Hydrogen needs how many? Just 1 electron. Now, what do you think will happen? Oxygen cannot just say, well, I've gotten 1 from you and I will manage that until I get another. No, that's not what will happen. Oxygen has to get it complete. So what will have to happen is another hydrogen will have to be invited to the feast. So another hydrogen is coming to the feast, and with the same 1 electron in the outermost shell, and this is hydrogen. So these two will be able to contribute 1 electron each to this oxygen. So what do we have? The structure will now look like this. So this is 1 hydrogen and this is the other hydrogen, and that is oxygen at the middle. And if we look at that, hydrogen is going to, this one is going to contribute is 1 electron, and this other hydrogen will also contribute is 1 electron. And oxygen will also have to contribute 1 because they have to share. And this oxygen will now be left with, because it's also going to contribute 1 here, so it will be 4 left in the outermost shell. So now, what do you think about the chemical formula? We have 2 hydrogens. So hydrogen, we call it H2, and 1 oxygen, that's H2O. Do you see that? So that's how the chemical formulas are formed because of the bonds. So H2O, 2 hydrogens formed a bond with oxygen. Now, can you do the same? Can I ask you to do the same for methane, right? Methane is CH4. Okay, can you do the same for methane? And let me know whatever you have in the chat area. If you struggle with that, then do let me know. Now, if you have all of these easy already, the other thing for me to just mention is what we call simple molecules. Simple molecules. So we have 2 types of structures. If you say, now talking about structures of covalent bonds, we have 2 types of structures, right? We have the giant covalent structure. Remember, ionic compounds will form giant ionic lattice. They don't have 2 types. It's just 1 structure for ionic compound. It is giant ionic lattice. But for covalent compound, it is either going to be a simple molecule, or they are going to form a giant covalent structure. And we're going to look at them one after the other. So here, of course, when you say something is simple, that means it's not complicated at all. So a simple molecule contains relatively small number of nonmetals. Small number of nonmetals like, say, hydrogen, chlorine, right? Oxygen, hydrogen chloride. These are all simple molecules. They only contain small numbers of nonmetals, right? It compared to if you have something like, let me say, 6H12, something like this. This contains more. It contains 6 carbon atoms with 12 hydrogen atoms. So this is going to be a giant covalent structure. So a giant covalent structure. So simple molecules only have few number of non-metal atoms joined together by covalent bonds. So remember, nitrogen can also be included. So all of these are simple molecules, and the molecules have no overall charge, so they cannot conduct electricity. Remember, for any atom to conduct electricity, they have to be charged. They have to have a delocalized electron to conduct the electricity. So they cannot conduct electricity. So that's one point. And substance of this molecule are usually liquid and gases. So they can either be liquid or gases. So when you think about all of this, hydrogen is a gas, oxygen is a gas, hydrochloric acid is liquid, nitrogen can be a gas. Now, chlorine has conditions when it's going to be a gas or it's going to be a liquid. So we're going to see that. Another example is if you'll have something like iodine. Iodine is a solid at room temperature, right? So above that, it's so that's why I said we're going to see there are some special characteristic with some of this. So, but however, just keep in mind, they can, for simple molecules, they can only be in two states. They can either be liquids, or they would be gases. They can either be liquids or gases. And another thing is that they have low melting point and boiling point. They have low melting point and boiling point. And the reason is because they have a very weak intermolecular forces. They have very weak intermolecular forces. Now, you can just check with the PowerPoint for the lesson on the notes to help you remember all of this. So this is what I'll be saying for now on this. And just to add, maybe to just clarify this, because I don't want to keep that to myself maybe until another lesson, but to add this, that fluorine and chlorine, that's talking about the group 7 elements. You know, we have fluorine, chlorine, bromine, iodine. I will just stop there. Now, just to talk about, you know, we said simple molecules can be liquid or gases. Now, for fluorine and chlorine, at room temperature, they are always gases. So at room temperature, they will be gases. So, and at room temperature, bromine is liquid. Okay, I have told you about iodine. At room temperature, iodine is a solid. So don't forget that. At room temperature, fluorine and chlorine will be a gas. At room temperature, bromine and iodine, bromine is a liquid, iodine is a solid. So thank you very much for paying attention. We are still left to talk about the giant covalent structure. I'm going to make a video to cover that in the next time. So just keep in mind, keep checking, keep doing what you're doing right. Remember to leave feedback, and I will see you in the next lesson. Have a wonderful day. Bye.